All right, question number 3. It's different than question number 2 because in question 2, everything divided evenly. So what do we do in a problem like question number 3 where we have something that'll be like an 8 divided by 3? Well, that doesn't divide evenly. So that's going to cause some different results than we got in question number 2 where we can just divide everything nice and evenly. So let's look at this example first before we dive into this question. Doing the same step where we swing that index to the back. So we're going to have x to the 11th divided by 4. So let's go ahead and take this off to the side and divide 11 by 4. So now the 4 can go into 11 really only twice because 2 times 4 equals 8. And it's going to leave us with the remainder of 3. We're going to stop there. We're not going to get into decimals. We don't really want decimals in our exponents. So what does this leave for my answer? Well, we're going to have x to the second power on the outside because that's how many times it divided evenly. I'm going to copy my fourth root, x, and the power on the inside is going to be that remainder, 3. So a lot of numbers are kind of moved around here. 2 goes on the outside. What's a remainder goes on the inside. We can check our work by saying 2 times 4 equals 8 plus 3 equals 11. So everything works out nice and evenly. Let's go to our question now. We're going to split this up. Cube root of y. Okay, now the first part is the cube root of 27. Well, that's just 3. 3 times 3 equals 9 times 3 equals 27. So we can take care of that number and just move on to our x, where we're going to do the same thing that we did in the previous example. We're going to move this 3 over to the back. So we're going to have x to the 8th divided by 3. Now let's actually divide that out. I'm going to divide 8 by 3. Well, 3 goes into 8 twice evenly. 2 times 3 equals 6. And it leaves us with a remainder of 2. We're going to stop there. Now this is the part where we got to be really careful. I'm going to go ahead and copy my x cubed, cube root of x. Well, since it divided evenly a couple of times, we're going to have an x on the outside, and its exponent is going to be what it was dividing evenly to. And then on the inside is going to be my remainder, 2. So the number on top goes on the outside, the number that was the remainder goes on the inside. And that is all I'm going to do for that x. That is as simplified as I can get. Now moving on to the y, the number, there is no number on the inside, so we can just assume it's 1 because there's one y inside the radical. Now, if this number is not greater than or equal to this, we cannot simplify it any more than it already is. So since 1 is smaller than 3, we're actually going to leave that. We're going to just go ahead and bring this down. So we got the cube root of y, and then we don't forget our 3. So now I'm going to rewrite this. Everything outside the box is going to go together. So, or outside the radical, we got 3x squared. And everything inside the radical, we're going to combine into one radical. Does not change the value. The radicals are the same. The reason we can do this is because we're multiplying. Unlike question 1, we couldn't combine the radicals because they're not like radicals. That was because we were adding or subtracting. When you're multiplying, you can combine the radicals as long as the index, that 3, is the same, and it is. So that's why we can put this together, but we couldn't put the numbers in question 1 together. So note the different. Like radical only applies whenever you're adding or subtracting radicals.